So once we're moving from a simple web application that's running within our cluster to a more complex application, maybe we want to run in a multi-cloud environment, maybe we want to run thousands of pods that our application, our microservices depend on, and so on. In those cases, we do not want to deploy directly to our cluster. So in several of the previous videos, I directly run kubectl apply. Now, if you're not within a demo environment, if you're not within your own cluster space and you're not just setting up an example, you do not want to deploy directly to your cluster. You don't want to be the single point of failure who's doing manual deployments. So what can we do instead to be ensured that we have the high security in place as well as all the networking and everything set up correctly, and what we're doing within our cluster is actually replicatable across our environments? We can use GitOps for that. Hello there and welcome to another video of 100 Days of Kubernetes, the challenge where we aim to learn something new related to Kubernetes across 100 days. My name is Anais and today we are going to be looking at GitOps and ArgoCD. Now, ArgoCD is part of the Argo project family that is 4 different tools: Argo Workflows, Argo Events, Argo Rollouts, and ArgoCD. ArgoCD just launched version 2.0, so we're going to be looking at version 2.0. I'm not going to dive into the difference between 1.0 and 2.0. It's really great. It's a really great tool. So if you're familiar with both, you will see the difference. If not, then just be prepared to be overwhelmed with how cool of a tool this is. Now let's get started and take a look at how do we use GitOps? Why would we use GitOps? What is GitOps actually? And then how do we get started with ArgoCD? Like always, you can find all of the resources linked below in my public Notion page. So there are all the notes for today's video, introduction to GitOps, this really nice diagram that we're going to be looking at in my practical drawing in a second. And then we have all the different commands and everything that I'm going to be doing now. And if you don't have time to actually watch this entire video, or you want to have a quick intro, watch this video. Yeah. 1 minute about GitOps. Anyway, so let's jump over to our practical drawing. When we have here our Kubernetes cluster, we can either directly do kubectl apply and tell the Kubernetes API, hey, please do this and do that and deploy this and patch that and so on. However, this is the imperative approach of deploying resources. So we have the imperative versus declarative approach. What is the difference? So imagine we have a recipe, right? And the recipe tells us how to bake a beautiful cake. Here, these are flames. Okay. Now, we want to bake the same cake. You want to bake the cake, I want to bake the cake. Or I baked an amazing cake based on this recipe, and you want to replicate it for somebody's birthday, okay? So I just give you the recipe, and then you can create that cake. So you can create that cake if you follow that recipe. It's really likely that that will happen. So this is the declarative approach. I tell you what to do, and then based on that, you deploy it. You bake the cake. Now, the imperative approach would be us both mixing wild ingredients together. Those are different ingredients. This is a different ingredient. Maybe here's a banana that we put into the cake. And we mix all the different ingredients together until we have something that looks similar to that cake, but it will just be completely different. I don't know, it will look kind of like that. So we obviously want to have the cake instead. So the imperative approach is basically you do something until you have the desired state. So you do something until you have something that goes to what you want to have. Now, that is quite messy, and if we do that with our resources, if you do something and I want to replicate it, I won't likely be able to do it the same. If you tell me which buttons to press and the UI changes, I won't be able to do the same thing, right? So this is the imperative approach. With the declarative approach, you tell me what the end state is, and I just have to deploy the end state. I just have to take the end state and be like, okay, I take that, right? And it's already set up as such that I can just take it. So those are the differences, okay? This is imperative versus declarative approach. Now, when we have our Kubernetes cluster, and we have a bunch of different resources that we want to deploy in our Kubernetes cluster, we can define all of our resources within Git. So this is Git, let's say. And we put all of our different files within Git. And Git is taking care of that. So Git is our main source of truth, our version control. Source of truth. Okay. Everything that we want to deploy is within Git, and that allows you to pull from the same Git repository and myself to pull from the same Git repository. And Git will realize whenever there are any changes. Now, how do our resources go from Git to our Kubernetes cluster? To make that happen, we have to install an agent into our Kubernetes cluster. So this agent is gonna get installed inside our Kubernetes cluster. Yeah. And in this case, the agent is ArgoCD. Now, ArgoCD is based on custom resource definitions. And custom resource definitions, as we've seen in one of the previous videos, and you can check that out, are basically Kubernetes resources in themselves that extend the Kubernetes API. So we deploy these custom resources in our Kubernetes cluster. And then they are sitting there inside. They have their own, basically they have their rights within the Kubernetes cluster, their own security settings, who can basically, everything configured inside, okay? And then we tell this agent, please monitor this Git repository, right? So we tell the agent, please monitor that, yeah? And the agent is gonna keep track of the desired state within our cluster. The source of truth is the desired state, okay? So, and we want the desired state to be the actual state. That's within our cluster. So we want to ensure that the agent is able to pull the desired state from Git and deploy it within our cluster within the actual state. So the desired state and the actual state is always the same. Now for that, the agent, in this case ArgoCD for example, uses a pull model. It's pulling the state from the Git repository, and that's really important. So it's not that we are pushing what's in Git on our cluster. It's that our cluster, or the agent within the ArgoCD operator and so on, they monitor our Git repository, and if then there are any changes, they pull those changes from the repository and deploy them within the cluster. And this is different to a push model. So we have pull versus push model, yeah? The thing here is that if we would push the changes from outside into our cluster, for example, through a CI/CD pipeline, we can introduce additional security vulnerabilities into our cluster because the CI/CD pipeline would need additional access to our Kubernetes cluster, right? It would require access to deploy resources. It would require access to modify resources and so on. We don't want that. We want anything that can happen within our cluster be defined from within our cluster, not from the outside, right? So this creates additional security. So one of the benefits, where would we put it here, is security, confidence in our deployments, and higher observability. I do not know what you are doing on your own machine. I do not know which buttons you press. But if we have a workflow that's universally defined, that between our agent in our cluster and our Git repository, then independent of whether you deploy changes or I deploy changes, the tests run and everything, and then ultimately the agent pulls those changes from our Git repository, then we can both be ensured that independent of who's deploying, those changes will be deployed, right? And that's really, really cool. So we have that if we're using GitOps. So GitOps in itself, to summarize, is a principle of how we want to deploy our resources. It's a principle of defining all of our resources within Git and using Git as our single point of truth for everything that we do. So let's see how we can use ArgoCD to deploy our resources. So I'm here within my terminal, and we're going to just create a new kind cluster. So if you have kind installed, kind help, like that. So you have a bunch of different commands, and we're going to create a new cluster, all right? And you can follow all of that through using my public Notion page. It's all defined there. Let me just pull this up a bit so you can see it properly. Okay, so we're going to create this cluster. It's going to take a second. Now on the cluster, we want to create a new namespace for ArgoCD where we're going to deploy all those custom resource definitions that ArgoCD is dependent on. So we're going to create that namespace and now get namespace. As you can see, we have here ArgoCD, we have the default namespace and then our local path storage. That's interesting. That's new to me. Anyway, so once we have that, we can deploy ArgoCD and we're going to deploy version 2 of ArgoCD. So we're going to deploy all of those resources. As you can see, there are lots of different resources that are defined here. Now we could take a more specific look at each of them. We're not going to do that. We're just going to check kubectl get all in namespace ArgoCD. And as you can see, it's right now spinning up all of our resources. So we're just going to wait until the containers have been created. And then we're going to go from there. Okay, all of the resources are now up and running, as you can see. So make sure to check them first before you move forward. Now we want to access the ArgoCD server. We want to access this server here that's right now connected to port, well, it's going to be connected to port 80. Here, this one. Okay, so we want to do kubectl port forward, and this will allow us to access it. Okay, so we're gonna go ahead, kubectl, not kubectl, localhost, host, and then we're gonna access port 8080. Now this will ask you to accept the risk of opening the site, right? Now, once we're here, let's open a new terminal. And here we want to first have a look at our password. Now, as you can see, this will return our password. Now we want to change that password, right? And for that, we first have to log into our local host once it's running. So username is admin, and the password is this password. So we're just going to copy that and paste it in. Okay, and now we want to update our password because this is obviously nothing we can remember, or I mean you could note down, but you generally want to update your password first. So this is the current password. We're going to copy it again. And then we enter a new password. Let's just call it admin and admin. So the password has been updated. It returns, yeah, I don't know. So let's log in again. We want to accept the risk, and admin, and password is admin. Okay, so we are logged in here now. So if we check if we have anything set up, oh, we have to provide probably something get app name. Okay, we don't have anything yet there. So we want to deploy our first application. Now let's first log in and see how it looks like. Admin. So as you can see, we don't have any apps running right now. You can see here all of your existing apps. You can manage some user information, read documentation, manage repositories, projects, and so on. So we can either create an app through the UI. So you just specify the app name. You can give it any name. Then you specify, well, default usually. You can use manual sync or automatic sync, depending on what you prefer. It's basically whether, like, how it's supposed to sync with your Git repository. And then you define your Git repository. And you have to make sure that if, for example, this is your Git repository, you want to use it as such. You don't want to go into your YAML files and then use that link. You want to use really the link directly to the root of your Git repository that you want to be using. I've tried the other path before and it didn't work. So you define that, then you define the path. In this case, my path would be charts and an example chart to my YAML files. Now you don't have to have a Helm chart. You can also deploy simple YAML files, right? It doesn't have to be a Helm chart. I'm just using in this case a Helm chart. And then the cluster URL, if it's the default cluster on which ArgoCD is installed, you're just going to use that. And then you define a namespace in which you want to install ArgoCD, the application. And then you will hit create. Now I'm not gonna do it through the UI, I'm gonna use the terminal to do that. And I have here a little pre-prepared command that I'm gonna be using. So as you can see, I say ArgoCD. This is the Argo client. Now I have linked in the Notion page how you can install the Argo client. And an app, create React app, and then this is the name I gave it basically. And then I define a repository where it's supposed to pull from. I define the path to my YAML files, which is charts and an example chart. And the destination server is my default Kubernetes cluster on which ArgoCD is currently running. And the namespace is default. So I'm just going to go ahead and create that, and that should deploy my application. So we can go here right away to the UI. Now, right now it's out of sync, meaning that the actual state within our cluster is not the current state, is not the desired state that's defined within Git. So if I say kubectl get all, since I wanted to deploy my app in the default namespace, as you can see, nothing has been deployed yet because the desired state from Git is not synced with the actual state yet. So I could run argo app sync react app. That's the name I gave my app. Or I can go ahead and sync through the UI. So I can just specify also additional parameters, as you can see here, and I can hit sync, and this should sync my application now from the desired state within our cluster from within Git to the actual state. So as you can see, this is syncing now, and it's progressing. It's like installing all of my resources, making sure everything is running correctly. So we just wait until this is finished processing. Now, this is syncing already, and we can have a look at get React app. So we can also follow it here within ArgoCD. So you will see that this is right now my application is healthy, meaning that the actual state is the desired state. And here basically all the different events from that application. I can see here additional information on how this application was deployed, where it is running, like how would I get to it in this case, and the Git repository that's connected to, and so on. Now, what happens if I make a change to my application? Let's see if it's synced here. Okay, it's still in processing. But basically right now, as you can see, I have over here, let's zoom out a bit, kubectl get all. No, this is not what I want to do. Here I have my service for my application. Now this is load balancer, but the thing is that my kind cluster doesn't have a type load balancer. So what do I do here? I want to change it into node port. So instead of changing it within my Git repository, which would be GitOps best practices, what I'm just going to do is I'm going to patch that service. Hope you can see that. I'm going to patch it to be of type node port. Okay, so I'm going to set it of type node port. It's going to be patched. Now, if I now go ahead and say kubectl get all, I can see that now my service is of type node port. Now when I go ahead and then check again my application, it should become out of sync now. Like it should become unhealthy soon. So maybe if I sync it again, well, it's already out of sync labeled here. And now when I try to synchronize it, it shouldn't be able to because the state, or it's just going to overwrite my state, the state that I defined before. So let's have a look. Kubectl get all. Yeah, now it changed it back to type load balancer, as you can see, because I basically said, please sync the app. And now it's changed it back to what's defined in Git, right? So I manually said, hey, let's change it into node port, my service. So I changed it into node port, but then once I wanted to sync with my desired state in Git, Argo was like, hey, we wanted it to be type load balancer, not node port. Let's keep it load balancer. So I changed it back. Now we don't want to have the load balancer, so I'm just going to patch it again just to show the application. You can obviously also clone my Git repository and then change it by default to type node port. So now that we have that, I want to forward my kubectl port forward, and then here to access it. So as you can see, since I changed it again to node port, it's out of sync right now. If I go localhost 8000, I can see my application. So obviously this is not how you want to go about it. You want to keep all of your states within your Git repository. So for example, if you look at the values, we should see load balancer. So that's why it's consistently changing it back to type load balancer, even if I patch it through kubectl to be of type node port, okay? So we don't want to change anything to our resources that are within our Kubernetes cluster through the manually through the terminal. We want to do it through Git by deploying changes. So what I would want to do instead is change this within Git, like for example, modify this directly here. Let's say I'm changing it here to type, where is it now? Node port. Okay, and I'm just gonna be evil and just deploy directly to my main branch. And now that here it's deployed, the node port is deployed to my main branch, I can go back to the UI and I can say sync. And it should now be able to sync it, but also show of type node port. So as you can see, my application is healthy, it's synced. And now we can have another look at, let's just open another terminal. Kubectl get all. And as you can see, now my application is of type node port, but it's also healthy because I made the changes through Git. This is it for today. I hope it was useful. If it was, please remember to hit the like button and subscribe to my channel for upcoming videos. Also, if you watched this far, you might want to join our DevOps learning group, i.e. our Discord server, where a bunch of amazing people come together, talk about cloud and DevOps and everything related. Also, you might want to join and subscribe to my weekly DevOps newsletter, where I share free online learning resources from across the space from amazing people such as yourself right to your inbox every Sunday. Subscribe below. Anyway, I hope to see you in one of my upcoming videos. Have a lovely day. Bye bye.